Alright, so for question 1, we have a asterisk b is equal to ab over 3. Find the identity element. Alright, to find the identity element, let's first solve question 4 so that you can understand the basic. Question 4 is like a basic question, right? Then we'll come back to question 1. So for question 4, let me change this to brush before I forget. So question 1, so question 4, Jerry. So for question 4, we have the operation is defined by this triangle, and x, the triangle y, x is equal to x squared plus y. They said we should find minus 2 delta 3. Minus 2 delta 3, right? So now whenever you are doing binary operations, they can be defined by any element, right? It can be defined by delta, it can be defined by asterisk, many other things, right? So now whenever they give you what the operation is defined by, they will also give you what you are to find, right? So now here you have to find minus 2 and 3. So what you are just going to do is that this first one here represents x, while the second one represents y, and then you are going to put it into the binary operation. So it looks something like this. So we have x delta y, then we have minus 2 delta 3. So this represents this and this represents this. So now if this is equal to x squared plus y, it means that this will be equal to minus 2 squared plus 3. Right? Remember, I put my minus inside the bracket. Don't make the mistake of putting it outside, because everything here is what is x, and x is squared, right? So here we have minus 2 squared, which is going to give us 4, plus 3, and this is 7. Very easy, and that is your answer. Alright, so let me clean this up. Alright, so for question 1 now, back to question 1. So now for question 1, we have a asterisk b is equal to ab over 3. But this one, they did not give us any number, right? They're asking us to find the identity. The identity of a binary operation is given by e. Is given by e. And now when you do the binary operation of a with e, it's supposed to be equal to a, right? So now, just like the way we solved number 4, where we put a, e, where we put the minus 2 and 3 as the values for a and b, here we are going to put a and e as the values for a and b, right? Because if we have something like this, ab over 3, it's supposed to be equal. So that means this one, so when we put a and e here, we're going to have we're going to be having ae over 3, right? Because e is now replacing b, right? We're finding the identity. And don't forget, a asterisk e is equal to a. So which means this a asterisk e that we have done now is supposed to be equal to a, right? So we have ae over 3 is equal to a. We'll cross multiply. So we have ae is equal to 3a. Remember, we're looking for e, right? So here we can just cancel out a, or divide both sides by a, anyone, and e is equal to 3. So this is the identity. Let me just go over this again so that it is clearer. Let me go over it again. Alright, so we are given a binary operation, and the binary operation is defined by a asterisk b is equal to ab over 3. Now we have to find the identity element. The identity element is equal to e, right? And whenever you do the binary operation of a asterisk the identity element e, it is supposed to be equal to a, right? So now this is the binary operation. Now let's do the a asterisk e let's do a asterisk e in this binary operation, right? Because a asterisk b is ab over 3. This e is now representing your value for b, right? So you are going to be having ae over 3. This is equal to a asterisk e, right? Just like the way we did question 4. So now that I've gotten a asterisk e to be ae over 3, remember that a asterisk e, the binary operation of a with its identity is equal to a, right? So we're going to have a e over a, because this one is equal to this and is equal to this, right? So we can replace this with this, so that's equal to a. So this is 3. So we have ae will cross multiply is equal to 3a. Divide both sides by a will cancel out, so we are left with e equals to 3. So that means 3 is the identity element. So let's go to question 2. It says if an operation is given by x asterisk y, x asterisk y is equal to root xy, that we should find x when x asterisk 2 asterisk 18 in bracket is equal to 6. So what you do in this situation where you have something in bracket, that you do the bracket first, right? Just like board mass, you do bracket first. This is bracket of division, multiplication, addition, and subtraction. So you do the bracket first. So we're going to do this one in the bracket first. So we have 2 asterisk 18, right? Well, this is x asterisk y, and this is equal to root xy. So we're going to put this one is representing x and this is representing y. That's going to be equal to root 2 times 18, and this is going to be equal to root 36, and this is going to be equal to 6. Very simple. So this is 6. So it means that everything here now is 6. So we're going to change, we're going to rewrite it. So we're going to be having x asterisk 6, and this is equal to what? And this is equal to 6. Now we're looking for x. Remember, we're still going to use this one again to solve it. So we have x asterisk y is equal to root xy. So already from here you should be able to tell your answer. But let's solve. So this is representing x and this is representing what? This is representing y, right? So x asterisk y, that will be root x times 6, right, is equal to 6. So here we have root 6x is equal to 6, and here we'll square both sides so we can eliminate the square root. So we're going to have 6x is equal to 36. Divide both sides by 6, so we have x is equal to 6. X is equal to 6, and this is our final answer. To check whether it is correct, we'll put 6 as x here and see if we will get x. So let's do that. So we have 6 asterisk 6, right? And remember, this is equal to xy, so 6 times 6, that's equal to root 36, and this is 6. So it means that it is correct, right? So x is 6 for this question. Alright, so let's solve the last one, question 3. Okay. Alright, so question 3 now. Question 3 is also very simple. Let asterisk be a binary operation of n defined by a asterisk b is equal to a minus b plus ab square. And they say we should find 4 asterisk 5. So wherever we see a, it is 4 and b is 5. So a is what? 4 minus 5 plus 4 times 5 square. It's only the 5 that has the square, not the a. If it was the a and b, we'll be having bracket like this, right? But we do not have bracket like that. So it is only the b. So we have 4 minus 5, which is minus 1, plus 4 times 5 square, which is 25. So we have minus 1 plus 4 times 25 is 100. So we have minus 1 plus 100, and that will give us 99. And that is our final answer.